Hello everyone, this is Back to Basics, and today we'll be covering sine, cosine, and tangent ratios. So what exactly is sine, cosine, and tangent? Well, they are ratios that relate the sides of a right angle triangle and helps with identifying its angles. So to actually begin using the ratios, we have to first understand what is the adjacent, opposite, and hypotenuse, right? What are they? Well, they're essentially just names for the sides of a right angle triangle. So looking at this triangle over here, I have it already labeled A, B, C. Let's label our hypotenuse, opposite, and adjacent. So our hypotenuse will always be the side length that is opposite to our right angle. So right angle C, our hypotenuse will be side length C. And our angle theta, which is just a name for an angle. We also have different names such as beta or alpha. I will show you more over here. So angle theta, the side length that is opposite to angle theta, which is side length B, will be our opposite side. I know it's a bit confusing, but we will have more practice over here. Now, whatever is left is essentially just the adjacent side length, which will be over here, or it's just directly beside our theta. However, that is a bit confusing to remember. So, looking at this triangle up here, let's label the hypotenuse, opposite, and adjacent. So, to begin, our hypotenuse is always the side that's opposite to our right angle. So, hypotenuse will always be here because it is opposite to angle Z, which is our right angle. Now, angle theta, which is the acute angle and the angle that we are given to look from, the side length that's opposite to angle beta is YZ. So this will be our opposite side. And whatever is left over is essentially our adjacent. Now, how do we actually apply these ratios to an actual question? And what essentially are these ratios exactly? And how do I remember them? Well, a really good acronym that you may or may not have heard of is called SOHCAHTOA. What this acronym essentially is, it's just sine, cosine, and tan. So the beginning acronym letter, which is S, C, and T, corresponds to sine, cosine, and tan. And then the letter that's always in between these acronyms, as there's a space over here, such as the O, the A, and the O again, will always be our numerator of the ratio. In this case, the O corresponds to the opposite. And then the final letter within this acronym is the H again, and then A. That goes in the denominator. So if I were to repeat it, if we just look at the first acronym, SO, which is SOH, the S is the sine, the O is the opposite, which is in the numerator, and the H is the hypotenuse, which is always in the denominator because it is the last letter. Now let's actually apply this to a question. Obviously, I have these three ratios, but how do we actually use them? And how do we know which one to use them? Well, we have to find side C. So I would first recommend with labeling your angles. I would label this as A, C, this helps a bit. And now let's label our sides in terms of adjacent, opposite, and hypotenuse. As I mentioned before, the hypotenuse will always be opposite to the right angle itself. So in this case, we're trying to find side of the hypotenuse. Not side C, but rather the hypotenuse. So let's get rid of this. And we are given our theta, which is 35 degrees, and the side that is directly opposite to theta, angle theta, in this case, is AC, or it is 72 meters. So this will be our opposite. And whatever's left is the adjacent. So if we're trying to find the hypotenuse, we know our opposite, and we know the theta, then we have to determine which of the ratios to use. Now theta is of course in all of these ratios. However, if we're given the opposite and we're trying to find the hypotenuse, then the adjacent is never really used. So in this case, cos and tan, they both have the adjacent, but we're not using it. So we have deduced that sine theta equals to the opposite divided by the hypotenuse is the ratio that we have to use. I usually like to write out the ratio. I'll just do OPP and HYP as just a shortened form, but it's essentially sine theta is equal to opposite divided by hypotenuse. Now let's rearrange to solve for the hypotenuse. I'll do opposite operations, multiply this side by the hypotenuse, and now multiply this side by the hypotenuse. So then you're left with hypotenuse multiplied by sine theta is equal to the opposite. Put brackets here. Now let's divide by sine theta to isolate for our hypotenuse. So now we are left with the hypotenuse is equal to the opposite divided by sine theta. Now let's plug in our numbers. We know our theta, which is 35 degrees, and we know our opposite, which is 72 meters. So hypotenuse is equal to 72 divided by sine 35 degrees. Hypotenuse is equal to 72 and sine 35. 125.53 meters. Now, let's take a look at this question. So of course, we're not always going to be given the angle all the time. We have to look for the specific angle. In this case, if we're looking for an angle, that means two sides are most likely given. So we have to determine which ratio to use. Let's first start with what we can do. Let's label our triangle. So I'll label this as A, B, and C. So if we're trying to look for angle theta or angle A, that means we should label our hypotenuse, opposite, and adjacents. Let's just pull these guys over here. So, of course, I'm going to repeat what I've said before. The hypotenuse side will always be opposite to the right angle. So, angle B is our right angle, so our hypotenuse will be equal to 23 meters. Our opposite side will always be opposite to the angle that we are trying to find, or in this case, angle theta. So this will be our opposite, which is 13.5 meters, and adjacent is whatever is left over. So we are trying to find the angle theta. We're given the hypotenuse and we're given the opposite. Now we don't need the adjacent. So looking within these ratios, we have deduced that we don't really need to use cos, we don't need to use tan, so let's use sine theta. Is equal to opposite divided by hypotenuse. Let's isolate for theta, which in this case we have to take the inverse of sine. So how does the inverse look like? Well, it's just simply sine minus 1 opposite divided by hypotenuse. Now let's plug in our numbers. So theta is equal to sine minus 1, 13.5 divided by 23. So now theta is equal to 13.5 and 23, 36 degrees. Now, I want to go over a brief concept with our opposite and adjacent. Of course, not all the time that we're going to have our setup like this. Sometimes side AB might be our opposite, or side BC might be our adjacent. It really all depends on the specific angle that you're looking at this triangle from. So, for example, if angle C were to be my theta, or the angle that I'm trying to find, then side AB will be the opposite instead, because angle theta, the side length that's directly opposite to angle theta, which is AB. And thus, our adjacent will be 13.5 meters. So if you're solving it like this, that means we're not using the ratio sine theta, we're actually using the ratio cos theta. Now, of course, I will do this example right over here. So cos theta is equal to our hypotenuse, our adjacent, divided by our hypotenuse. So, like I said again, rearrange for theta. Adjacent over hypotenuse. And now let's plug in our values. Theta is equal to cos inverse of 13.5 divided by 23. So our angle is equal to 54 degrees. And now this is true because a right angle triangle, or any triangle, is 180 degrees. And if we add up 54 plus 90 plus 36, we would get 180, because our right angle is always 90 degrees. Thank you for listening, and these are some practice questions which you can try by yourself if you would like to. Have a wonderful day.